Assalamualaikum and a very good morning. My name is Nur Anis Natasha. So today I will present my final year project review report entitled Field Properties and Combustion Characteristics of D.strictus, Buluh Sumbiling and B.vulgaris Buluh Minyak. So this is the introduction of my review report. Global energy sectors are facing the vital challenge of sustainability and energy resource diversification. Therefore, it is a matter of utmost importance to pursue renewable resources with a sustainable supply. Rising energy demand, the depletion of fossil fuel reserves, and related environmental issues have necessitated the generation of heat and energy from the alternative renewable resources. Bamboo species are giant woody grasses used as a renewable resource all around the world, and several types of research on a wide variety um, of bamboo species have been carried out, and findings have shown that bamboo could potentially be used as a suitable fuel because it shares the variable fuel features given in other woody biomass. Biomass is stated that bamboo has great potential to be used for the energy production, and biomass is also one of the important options for the renewable fuels used to minimize the carbon dioxide emissions. As energy feedstocks, many types of biomass are used, and bamboo is recognized as the possible raw material for future bioenergy programs. So this is my objective to discuss and review the field properties and combustion characteristics of the Buluh Sumbiling and Buluh Minyak. And the second objective is to compare the field properties and combustion characteristics of D.strictus, Buluh Sumbiling, and B.vulgaris Buluh Minyak that have been done by researchers from the previous studies. So this is the species of the bamboo, D.strictus, known as the male bamboo, and it is one of the most common bamboo species. It provides many environmental functions such as soil and water conservation and erosion control. The species is widely cultivated as a source of the raw material for paper mills and for a diversity of other applications including building, furniture, agricultural equipment, musical instruments, and so on. Next bamboo is the Bambusa vulgaris. Bambusa vulgaris is ordinary bamboo that commonly known as the golden bamboo, which is a species that is a clump open bamboo. Bambusa vulgaris have a high nutritional content which can be used as a food source and have been applied in a variety of traditional treatment systems to treat a variety of human illnesses such as asthma, fever, and pain that all cured, which is the chemical found in the bamboo leaf. This bamboo is primarily used in the light construction such as the houses, huts, boats, fence, and scaffolding. So in my review report, I use bibliometry analysis to identify and analyze the scientific performance of the articles, authors, countries, and journals based on the number of citations to reveal the trends of the field studied through the analysis of the keywords. So what is a bibliometry analysis? Bibliometry analysis is a statistical tool for evaluating and quantifying the value of books and the quantity of the people interested in a given issue and their growing rate. And it allows to perform statistical analysis of applications, organizations, people, and many others. The analysis based on bibliometric data is currently very widely use. It allows the quantitative analysis to be carried out objectively. Next, this is figure 1, which is the publications of bamboo charcoal research by year. So this is the bar graph of the annual and cumulative numbers of research publication on bamboo. So the highest publications of research on bamboo charcoal was 66 in 2018, while the lowest publications of the research on the bamboo charcoal were one only documents between the year of the 1950 until 2001. Next, documents by top 5 authors. Lin J.H. was the author with the most publications of the bamboo charcoal research, which is 41 documents. Wang Weiti was the author with the least publication of the bamboo charcoal research, which is 12. So the top keywords used to find the documents were charcoal, and bamboo. Next, this is the figure which is the most published documents by the top 10 countries. The top 10 countries are China, Taiwan, Japan, India, Thailand, the States, Malaysia, Indonesia, Israel, and South Korea. And China is the country with the highest published documents of bamboo charcoal, which is 392 documents that attributes 55%. So in order to find the field properties of D.strictus and B.vulgaris, we have to determine the physical and chemical properties for the both bamboos and calorific value and field value index, and proximate analysis and ultimate analysis. So this is the table of the field properties of D.strictus. In this table, it shows the ultimate analysis, proximate analysis, seed density, moisture content, grain density, calorific value, field value index, oscillus, and lignin. So this result is from the Kumar and Chandrasekhar. So the physical and chemical properties, D.strictus was the lowest base seed density, 0.48 gram per centimeter cube, compared to other bamboo species shown in table 2.4.1 because of its high energy content per unit volume. Biomass with the high density is recommended as a fuel. Bamboos typically have the highest hemicellulose content and lower lignin content compared to woods. And the content of the lignin was 23.5%, which was highest in the D.strictus, with the lowest in a B.vulgaris, which was 90%. Next, the calorific value and field value index. The values of calorific of the D.strictus was 80.8 megajoule per kilogram in the table, and for the field value index of D.strictus was 586. Fixed carbon was 70.6, which is low in D.strictus compared to B.vulgaris, which is 65.94, while edge content for D.strictus was 3.0 and 6.03. D.strictus recorded that the field value index is 586. High calorific value and low edge content in D.strictus and Bambusa vulgaris explain the high field value index of this species. Bamboo biomass is mostly made up of cellulose, hemicellulose, and lignin. So the pyrolysis rate will be faster for biomass with a higher cellulose content, whereas the pyrolysis rate will be slower for the biomass with a higher lignin composition. The field value index was calculated to identify their potential for the power generation. For the high-quality fuels, a greater field value index can be achieved. Kumar reported that lignin percentage is high, which contributes to the high heating of the biomass value. As you can see, this is the table 2.4.2, which is the Proximate analysis and ultimate analysis of the Bamboo vulgaris. So from the table, it shows the proximate analysis, ultimate analysis, chemical composition, and gross calorific value for the Bamboo vulgaris and the other bamboo species. So results on the bamboo biomass of the FCC, which is fixed carbon content, and VMC, known as volatile metal content, are presented in table 2.4.2 and table 2.4.3. In the bamboo biomass, the results indicate a high volatile metal content for both bamboo, D.strictus, and Bamboo vulgaris. D.strictus and B.vulgaris were 3.0 and 2.44, and lower ash content was seen in the D.strictus. In the table 2.4.3, lower ash content was spotted in the Bamboo vulgaris, which is 2.44. So this is the proximate analysis and ultimate analysis of the dangerous Calamus strictus. It was observed that the fixed carbon content for the D.strictus, which is 70.6, while the Bamboo vulgaris from the another table is the 23.24%. So this is the combustion characteristic of the D.strictus Buluh Sumbiling. So for the table, it shows the oxidative degradation zone and Shah zone comprise to the initial temperature, peak temperature, maximum temperature rate, and temperature range. So for the D.strictus, the initial temperature in the oxidative degradation zone is 243, and while in Shah combustion zone, the initial temperature is the 364, and maximum combustion rate in the oxidative degradation zone for the D.strictus is 0.5833, while for the Shah combustion zone is the 0.2091. So this is the figure 2.5, which is burning profiles of the dendrochromic administrators. So so this is the TGA graph. We see which is the TGA is the thermography metric analysis used to evaluate characteristics of the combustion of the 5 bamboo species, and the dark blue one represent the D.strictus. So the maximum passive zone combustion rate is 0.20, and what was reported for D.strictus at the temperature of the peak of the temperature, which is the 395 degrees Celsius. So the combustion reaction might be assisted by airflow, and the process of the burning included loss of volatile matter, and this is called the active pyrolysis zone. The evolution of volatile compounds formed during the decomposition of the hemicellulose and cellulose can be related to the loss in the active pyrolysis zone. So according to the table 2.5, the highest combustion rate of the 0.583 was discovered for this at a peak temperature of 293 degrees Celsius, and the presence of more volatile matter in bamboo biomass makes it more suitable for the fuel production. And Bamboo vulgaris stand out as a suitable feedstock based on its low ash content, 2.44%, high fixed carbon content, 23.2%, 33.24%, and high calorific value, which is 19.62 megajoule per kilogram. In conclusion, the physical and chemical properties of the both bamboo species were different. The species with the highest energy potential will because the high fuel value index, calorific value, and low ash content. The burning profile of the biomass slightly exhibit variance in their combustion characteristic. And the new and my recommendation, the new approach needs to be carefully explored in order to make use of the bamboo biomass, but also prevent or minimize vulgaris to the environment and the human life. In order to explore the characteristic of bamboo to be used as a biofuel, the number of bamboo biomass research should be unlimited. And that's all from me. Thank you.